that it is recording.
Hi, Steve. Can you hear us?
Yep.
Wonderful. We were just checking audio, and are you able to see the screen that has the says CEOS Coast ad hoc team? Okay. Then let me see if I can try to play this video for you.
Hello viewers, and a warm welcome to our presentation. This brief talk highlights
Are you
the
hearing
CEOS Coast
that?
Application Knowledge Hub, or AKH. It represents a preliminary prototype designed to help us.
Hello, Steve.
Hello viewers, and a warm welcome to.
Nice to see you.
Yep, the video worked.
Wonderful. And you were able to hear Prasanji. Okay.
Yep.
Okay, good. We have a mix of live speakers as well as recorded. And as you know from past watch meetings, I'm not the best with audio visual technology, but thanks to Jerome and his mom, he figured it out. He said his mom paid for him to go to school, so he figured that stuff out.
Yeah, I'm a lucky boy. And well, we have click and share. So basically you click and then it shares.
Yeah, it's fun. I would never do that. Would any of you besides Jerome have thought to push that button to solve all our problems? I don't think so.
No, I wouldn't. I didn't stick at school.
Too easy.
That's
No.
Mum.
Yeah, we didn't even have to call her.
The only thing I can tell the audience is that all the sound level in all the videos we're going to play are at different levels. So keep your hand on the volume button on your side.
We'll do our best.
We didn't have the same studio.
Lazar, the second one that was the most hard for you to hear, she's going to present lives.
Oh, good. Because even with my amplifier pulled back.
Rachel, would you like to try screen sharing?
Yeah, let me see if I can try screen sharing right now.
Yeah, we can hear you great.
Okay, awesome.
I don't know if I have to stop screen sharing. Do you think?
Let's see. It says I'm now the presenter.
Okay.
Let's see. Is this working?
We don't see it. It's too big. Can you make it smaller?
Is that working?
Yes, perfect. Can you click through?
Okay. Is it moving through?
Yeah, it's working. Perfect.
Awesome.
So then if you could stop sharing, and then I'm gonna get my superpower back, Jerome.
Huh? What?
How do I get my screen back?
Oh, you lost it? Oh, that's.
Do I click share
Yeah,
again?
you can share again.
No, it seems to turn because it's red. So it's more what we put on our screen. So what about view?
Where's the view? I don't even see it. Ta-da.
Voila.
Oh my God.
And my dad also paid for my study.
Sit over here. Well, we can thank your mom first because.
You speak French? My mom taught me how to speak English when we went to California when I was 9 years old. And she said, I said nose. And then, no, she said nose, and I went like this. And then she said face, and I went like this.
We'll have them delete that from the video. Before it goes out.
But she didn't have a very good American accent. She said this.
Right.
It was on the SS or Stova from the PLO line.
Hi, Erin.
I know I'm not speaking for like another hour and a half, but I just want to do an audio mic check with you.
Yeah, we hear you perfect.
Perfect.
Share your screen.
Sure. Let me.
That will give me time to practice something.
Okay.
Hello. Hello.
Practice my own skills.
Hello.
Nice to meet you in person. Yeah.
Yeah.
How's that?
They printed a
It works for me.
Came a bit late.
Jerome, can you do me a favor? Can you look at the screen? Are they able to see both of our screens? Online or just the pace one?
Yes, we can see this one.
The pace one.
And not the face.
Yeah.
Okay.
So
All right.
Yeah. Go ahead and, I guess, tab through anything. Oh, we see nothing.
We lost it. We stopped.
All right. Let me do it again. All right. All good.
Yeah.
Yeah, that's
Okay.
fine.
Perfect.
I think you're our last presenter.
I think I am. Yeah. I just wanted to make sure I'm prepared for an hour and a half from now.
Right. It's good.
Thanks, Maybeth.
Being prepared is good. You must have been a Girl Scout. Sonia, would you like to test your microphone and also share the screen?
Hi, good morning. Can you hear me?
Yes, we hear you.
Okay. Okay, yeah, that's good. Thank you.
You want to share your screen?
Oh, sure. Okay.
And you go after Geoscience Australia's video.
Let me actually.
We'll just wait for Hall to join if you don't mind, and then we can get started.
The meeting's obviously just finished.
Hey, Tom. Salut. Ça va?
So can you see?
We
My
do, but
screen?
it's not in presenter mode yet. Perfect. Yeah.
Okay.
Yes. Thank you.
Okay.
Very much.
Okay. Oh. By the way, my talk is after emerging topic of shorelines, right?
Yes. Yeah, that's correct. I'm just going to.
For the people in the room, should we use that computer?
You can probably do it from WebEx.
Hmm?
You could just do it from your WebEx.
You think I can share with it?
Just like this.
Share.
Yeah, there you go. So it's just not this one.
Also start with that one. I'm ready.
Okay. It's a bit slow, isn't it?
Great, well, welcome everybody. So I have the honour of moderating this session. And to introduce myself to maybe those who don't know me, I'm Mary-Claire Greening. I am the Executive Officer for CEOS and I work here at ESA. And it gives me great pleasure to welcome you to this CEOS Strategic Implementation Team Technical Workshop side event, during which we'll be treated, I believe, to a series of demonstrations and products and services and tools that have been developed by the COAST ad hoc team. COAST, I'm sure you will know, expands into coastal observations, applications, services and tools. And the team are now reaching the end of their third year in operation and are looking forward to what's next for them within the CEOS framework. And we'll be discussing this more at length at the workshop, specifically on Thursday. So I encourage you to attend or dial into that if you can. But for this session, we will be shown, be hopefully treated to demonstrations of what's been developed for coastal regions over the past few years, as well as some interventions on the potential for coastal product developments that existing or new missions can afford us, including expansion of pilots into polar regions and across broader blue carbon themes. So the format we're going to follow for the next hour and a half will be successive short 5 to 10 minute live or recorded presentations. Hopefully you've all had the agenda. There might be time for a quick 1 or 2 minute, 2 questions after each speaker, but we'll see how time goes. We hope to have a few minutes for audience engagement on future plans following this ambitious list of demonstrations. So without further ado, we'd like to begin with the Application Knowledge Hub, which is a foundational task of COAST's efforts and the portal through which users can access COAST products and other openly available data sets. And this will be presented by Dr. Dash of NOAA.
Can we just ask for an audio check from those who are joined online?
There is sound,
Okay.
but he can hear.
Who?
He has a problem with his sound.
Okay. So if you're not able to hear us, we think that it's a problem with your sound. So just maybe try troubleshooting that again.
Yeah, I can hear you.
Yeah.
Okay, Megan can hear us.
Well, now we can't hear you.
Hello, viewers, and a warm welcome to our presentation. This brief
Do you hear it now?
is the CEOS Coast Application
Yes.
Knowledge Hub, or
Perfect.
AKH. It represents a preliminary prototype designed to help assess the dynamic state of our coastal areas and also monitor events. My name is Prasanjit, and I'm proud to be a part of Paul's vision on coastal applications with satellite and ancillary data. The names of other contributors from NOAA are also included, and I want to emphasize that AKH is not a solitary endeavor, but represents a part of a larger collaborative effort involving organizations like ISRO, JPL, Geoscience Australia, and others. Last July, an extended presentation and live demo were made to the CEOS Coast team. Today, I will be brief, mainly intending to introduce AKH to a broader audience and assist in exploring it independently. We all here are familiar with CEOS, and as a reminder, COAST is an acronym for Coastal Observations, Applications, Services, and Tools. Its vision is to contribute to coastal safety and restoration. Safety in relation to what? This word cloud summarizes events threatening our existence on the coast, originating from various parts of the Earth system, including human actions and the atmospheric influence of substances like NOx and SOx. It also underscores the delicate balance in nature, and if one of the cogs in the Earth system is off, it can have consequences on the broader coastal ecosystem. So what is AKH? First of all, we all know that coastal areas are critical to our survival due to their high population density. Ironically, these areas are challenging for satellite observations due to littoral zone response to the electromagnetic signals with a mix of land, sea, and shallow water. In addition, complex weather systems, boundary currents, various ocean circulations, and dust and aerosol effects further complicate coastal studies. Notwithstanding, with improved sensor characteristics, satellite data are helpful enough to be explored in conjunction with other available information to get the best value from an integrated approach. Following this and in this context, we have conceptualized the COAST Application Knowledge Hub. Also, we released the alpha version at the end of June this year. The image you see here is a screenshot of the AKH online tool, and the URL is given here. While the importance of being online is obvious, let's focus on the name as shown in this pyramid here. The word knowledge here specifically refers to an actionable and interpretable summary of information. For example, we have sea surface temperature and chlorophyll A from infrared and visible data. When we observe something like El Nino HABs or changing trades, those are all examples of knowledge. That's why the name is Application Knowledge Hub. This slide shows the overall concept and input data for the AKH. Following the COAST approach, the acronym COAST, coastal processes can be broadly classified into sea to land and land to sea, and they capture various physical, biological, and ecological aspects of the coastal environment and habitats. And when these processes significantly impact the coast, we refer to them as events. So physical environments can be understood in terms of sea surface temperature, winds, flooding, inundation, and geomorphology such as shoreline, bathymetry, and hydrology as well. Likewise, water quality indicators such as chlorophyll A can help identify blooms. Seagrasses, mangroves, etc. are examples of habitats. Other phenomena like plumes, oil spills, and slicks can also affect the habitats. In addition, social indicators are also needed for this kind of coastal study. And so far, we have these types of data for the US coast included in the AKH. Looking ahead, we may extend the potential for sea-to-sea effects, such as oil slicks of natural origin and air-to-surface interactions, such as increased atmospheric CO2 leading to acidification. Infographics on this side indicate that these data go into the system and generate specific visualization and analytics. The output includes map visualization in an integrated way. Some of them are already available and some are in the pipeline. Now, coming to the infographic elements, that is the type of information and factors needed for coastal studies, including satellite and non-satellite sources. The sources are mostly non-NOAA and some NOAA and are noted in the table. This is a very busy table, so to avoid getting lost in the weeds, let's look at the main headers and colors. In light blue, we have satellite ocean products like SST, chlorophyll A, sea level, salinity, winds, water detection data, and true and false color imageries. Non-satellite data fall into two distinct groups, the curated group in light brown and the contextual group in light green. These data complement satellite data and serve validation purposes as will be needed. But what do curated and contextual mean in this context? Curated indicates the data have been acquired and post-processed likely to subselect our domain of interest, for example, NDBC and US geostation data, hurricanes from NCI IB tracks, oil spill locations from NOAA Office of Restoration and Rescue, or HAB locations from UNESCO HADAC. In addition, we have a bunch of contextual information, including base and reference layers, hydrology, social indicators for the US coast, land ecology, and land interface like the USGS Coastal Ecological Unit. Finally, in deep blue, we have higher order information based on research, either in-house generated or available as reviewed publications. These include ocean parameter trends and coastal land loss gain rates. Now, very briefly on the technology part, AKH has a client-side architecture and utilizes cutting-edge technologies to seamlessly display multiple pieces of information. The raster tiling system draws inspiration from NOAA Ocean View, incorporating a modified version of the JPL MRF technology. For displaying vector data, AKH employs GeoJSON for smaller datasets. However, vector tiling comes into play when handling larger vector datasets. It leverages Google Protobuf and the Mapbox vector tiling encoder and decoder. Interactive plots of station data and on-the-fly minor mathematical operations are done in the numeric.js library. Don't worry much about it. We can discuss it offline if someone is interested in technology. These two blocks here highlight some map controls and interactions and also some scientific features available in the AKH. This slide here shows a few features available in AKH. but there is a lot more to explore and discover. The alpha release version is available for exploration by the audience, and I strongly encourage you to explore it, which includes a graphical user onboarding module in the top right to get yourself acquainted with the AKH features. The first image here is interactive plots of data from various NDBC stations or National Data Buoy Center stations. As one clicks on the station, additional information is also available in this table. The bottom one is a land cover land use map from USC CAP. We also plan to include the ESA 10-meter LCLU in the future. I also highlight that this application is designed to be mobile friendly, ensuring accessibility across different devices. Additionally, we have exciting features on the horizon, including event maps or story maps. A story map provides a point-wise guided tour of events with a scrolling narrative to display collated information. You'll see some of these in the beta version. To summarize, the CEOS Application Knowledge Hub is an online tool for coastal assessment, monitoring, awareness, and possibly contributing to recovery efforts. It had an alpha release recently to test the data pipeline and ascertain that the processing chain works seamlessly. The AKH is designed to enable simultaneous displaying of a range of parameters and information necessary for studying coastal changes listed here. We still have a few wrinkles to iron out, and the beta release will be made sometime in 2024, but this should give you a feel for the potential of AKH. The next slide has some open questions and 4 more slides on future extension plans. I'll not discuss those as they're preliminary, yet self-intuitive. They are included as part of this video presentation. You may take a look later and we'll discuss those on another occasion. The URL is on the cover slide and on the backup slide if you want to explore the page independently, and feel free to reach out if you have further questions. Finally, look at the message about societal benefits above. So this concludes the talk. Thanks for your attention. I'm signing off, leaving you with a set of open questions and backup slides. Cheers.
That's nice. You know, the question.
Yeah.
Think about it.
Thought it was done. Still on. Okay. Next up, I think we have Rachel. Rachel, are you able to share your screen?
Absolutely. Let me see if I can pull it up right now.
I guess while she's just showing her screen, there were some questions on there. I guess we have access to these videos? Or?
This we are recording. We will post this for review. I can also make a link to the videos directly.
Yeah, that would be great. Thank you.
If we could just pull out the questions directly and distribute them, just to make it easy for folks to see them. Thanks.
Okay, Rachel, take it away.
Alrighty, thank you so much. My name is Rachel Lazaro, and today I'm going to be talking about some work that we've been doing on a habitat suitability index for submerged aquatic vegetation in the Middle Peninsula pilot area. So this work is falling under the CEOS Coast goals for the land to sea interface, since we're tying together water quality and habitat mapping in a sort of cross-cutting analysis. And aside from being a pilot area for CEOS Coast, Virginia's Middle Peninsula, which you can see in the upper right-hand corner, is also a NOAA habitat focus area. So there's a lot of work being done across NOAA line offices to bring together resources and new analysis for this geography. When it comes to seagrass or SAV in the Middle Peninsula, it's been on the decline since the 1950s, and current monitoring efforts in the region are intensive with regards to both time and money. So this project was a feasibility study to see how we could use satellite data for water quality to characterize condition at seagrass beds over time. Rather than directly measuring the extent of the SAV beds, we're looking to see if different indirect factors could be used to determine suitability for SAV beds. We wanted to look at this at a few different spatial scales, so we developed a Habitat Suitability Index, or HSI, using Landsat 8 data as well as data from VIIRS SNPP. In addition to that, we really wanted to assess the best combinations of atmospheric correction and water quality algorithms for Landsat 8 in this particular region of interest, and then extend to the larger Chesapeake Bay. So for this Habitat Suitability Index, we were really testing two different methodologies. One was a basic thresholding method that was using literature values for each water quality parameter that we chose, and the other was a maximum entropy approach using Maxent software to utilize machine learning in optimizing suitability based on input raster layers. And then with this, we were comparing the results to the extent of seagrass beds taken from annual survey data sets. So in terms of the satellite data that we were using, we had a Landsat 8 data set from 2013 to 2022, where we used the OC Smart atmospheric correction to generate chlorophyll and turbidity products, and the Acolyte software to generate a KD product. And we obtained a surface temperature product from the USGS Analysis Ready dataset collection and accessed it through the CEOS Analytics Laboratory Jupyter Hub interface. For the VIIRS SNPP data, we were gathering products for chlorophyll, KD, SST from the NOAA Coastwatch East Coast node, and we also utilized partner data sets from the Virginia National Estuarine Research Reserve, Chesapeake Bay Program, and Virginia Institute of Marine Science for our in situ data. So for our literature-based thresholding methods, on the right you can see we sort of have a high, medium, and low suitability thresholds that we were applying to our raster layers. We were exploring a few different weighting option schemes identified through literature review, which suggested that KD and SST variables would be more impactful to SAV suitability than other variables. So once we had these designations, we applied these to seasonal rosters, as well as a composite of the entire growing season, and evaluated that against the following year's SAV extent. For our Maxent approach, we were using the same seasonal time designations, but instead we're utilizing the software distributed by the American Museum of Natural History, which combines presence points of known SAV locations with background points of the domain of the study area. And the resulting machine learning algorithm gives us a relationship between these known locations and background points that can be interpreted as suitability on a scale of 0 to 1 for each point in the study area as being hospitable or inhospitable to SAV beds. To evaluate the resulting layers, we applied thresholds and then determined a binary of seagrass versus non-seagrass pixels, and then used a contingency table like this to compare the rosters. So the scores that we were most interested in are shown on the right, where we were trying to maximize the probability of detection and the percentage correct, while also minimizing the false alarm rate, which is the probability of false detection. So here's an example table that's summarizing some of the results that we had from our Landsat 8 dataset with the maximum entropy approach, where we found that the highest probability of detection was utilizing rosters generated from the entirety of the growing season rather than from just individual seasons. So with our end analysis, this gives us a visual comparison of the SAV HSI for Landsat 8, which is seen on the left, and the VIIRS, which is seen on the right, where the areas in green are shown as areas that would be hospitable to seagrass growth, where the areas in red would be inhospitable. So by using two different spatial scales, we're able to see some of the differences that these satellites can provide in terms of suitability for SAV. So our main takeaways from this project have been that the Maxent methodology gave us a higher probability of detection than our original literature-based thresholding approach. And across the board, KD was identified as the most important water quality indicator for SAV extent. In addition to that, we found that there was a little bit of disagreement between the Landsat and the VIIRS dataset as to the second most important variable, with Landsat suggesting chlorophyll and VIIRS suggesting SST. And overall, we found that there were slightly higher scores for the probability of detection with the VIIRS dataset rather than Landsat 8. We're still working on this, and looking forward, we're working to tune the results of the Maxent model, as well as extend the analysis to the entirety of the Chesapeake Bay in order to provide the most use to our partners in the Middle Peninsula, as well as the Greater Chesapeake Bay. And these rosters will be ingested into the Application Knowledge Hub for users to be able to interact with. I think that's all that I have on this right now. And so if anyone has any questions, I'm happy to answer about this work that's been done.
Great, thank you, Rachel. Does anyone have a a question they'd like to quickly ask before we move on?
Just to understand, not this particular attention, but what's the purpose of all those presentations? It will constitute activities proposed or done within CEOS later? Or
just demonstrating our progress to date
okay.
for the consideration of the coast actions.
Because today all those are being undertaken under CEOS.
Except for a few, which are forward-looking, that we'll get to a little later. Yeah, all of them are.
Okay, thank you very much, Rachel. Let's move on, just of time, to mangroves. Who's doing this?
Keel, I think. I wonder if we have an audio. Are you guys hearing anything?
No.
I have uploaded the presentation, I guess. Is it available with you or?
We have the volume maximum. We don't hear it though.
But we don't see it on space.
Not seeing anything, Mary Beth.
Okay, wait just a moment, sorry. We need Jerome's mom again.
Are we muted?
View? Is it view?
From search storm.
There we go.
Oh, okay, I'm so sorry, it's me. It's Mary Beth.
It's not you, it's for some reason.
Hello everyone, myself Nikhil Dede from SAC ISRO. I will present briefly on mapping of dominant mangrove vegetation.
The volume's very faint, Mary Beth.
So why mangroves? Mangroves are one of the key habitats and they are adapted to grow in loose soil and hypersaline conditions, as we all know. And mangroves have very high potential of carbon sequestration and they are known to sequester at least 4 to 5
Can
times
you guys hear it okay there?
more
Because it's very
carbon
faint on the
than purely terrestrial
virtual.
It's a bit faint. It's a bit faint.
Yeah, is it possible if I can, you can play the slides at your end and I can just voice over?
Yeah, you can mute him.
Okay, would you like?
Just mute the volume.
You can mute the volume of the recorded presentation, please. Hello everyone, myself Nikhil Dede. Yeah, great. So I'll quickly brief upon the mapping of mangroves. We have done the species level mapping of mangroves using Sentinel data. So this we are very well aware that mangroves are a critical habitat and one of the potential of blue carbon and also important in climate change perspectives. Also provides shelter and protection to coastal populations from such storms and tsunamis, and very important component in coastal biodiversity. Maybe the next slide, maybe I'll wait for this. Yeah, okay. So mangroves are, we all know that these are situated in quite inaccessible areas and there are swampy conditions. There is an effect of high tide and then it becomes, more inaccessible. And there is a very limited time, one can access such areas, particularly during the low tides through boats or through the road areas. And apart from this, there is a risk of having a wildlife, including snakes and crocodiles, which can also pose a threat for ground level data collection. So typically what we do is we go for a sample based survey for in situ field measurements by taking designated sample plots of 0.1 hectare or even lesser size depending on the sampling strategy. So coming to the mapping methods and issues, there are issues of getting availability of cloud-free data in coastal areas. This is one of the serious issue because there is a coastal environment. There are clouds, there are haze, there are aerosol contributions in the coastal areas, and it is really difficult to find a suitable window which is required for mangrove mapping. And then it is again complicated with the high tides and low tides as well, because some of the areas get covered during high tide and they get inundated. Now once we get data, yes, we can use traditional algorithms which yield acceptable accuracies, and now the recent methods like AI and ML which are highly dependent on the training data, they also give better accuracies nowadays. There are, sorry, is it possible to go to the back slide, please? Okay, anyway. So we have done, yeah, okay. So there are issues on mixing. Yes, fine, thanks. So the most critical issue is the mixing of mangroves with beach vegetation like casuarina and prosopis and all that. So segregating mangrove vegetation from these beach vegetation is one of the biggest challenge. And particularly in the case of India, there are other plantations like betel nut plantations, coconut, then mango orchards, fruit orchards, which make it even more complex to delineation of mangrove species. So we have used Sentinel-2 data, and we have January to April 2019 window we have used, and nearly 12 to 14 data were scanned, and a median function was used to find the suitable data. And since luckily we had large number of vegetation signatures and sample plots laid in mangrove vegetation, we attempted to go for random forest based method for mangrove classification, and we could get nearly 8 dominant mangrove vegetation classes in Sundarbans region. So that was using Sentinel-2 data. We also had attempted the same thing using IRS resource set to list 4 data. This has a better spatial resolution of 5.8 meters, and it helped us in detection of mudflats and few more vegetation communities due to the better spatial resolution. And apart from this, we also have large amount of field data where we have collected plant girth height in 0.1 hectare sample plots and a large number of geocoded photographs for monitoring and identification. Some of the other studies which we have done, and of course the way forward we are looking for the upcoming NISR mission, the NASA and ISRO synthetic aperture radar, which will be likely to launch in the next year, and an automated mangrove change detection using Sentinel-2 and Landsat 9 data, which we are targeting for 2026. This should be available for entire India, we are hoping for. And some other studies like we have attempted photosynthetic rates and seasonal GPP modeling and light use efficiency estimation, and what are the differences across different mangrove species, the rates of photosynthesis across different mangrove species, different seasons and different regions. So some of the results, and I thank these contributors and Nilesh Desai, Rashmi, Paul and Mary Beth and Rajiv Jaiswal from ISRO. Thank you all. Any questions?
Any questions?
Yes, I just want to, introduce about our JAXA's Global Mangrove Watch that I forgot to mention about. Maybe you already know about it. We have mostly a 20 years series of SAR consecutive data sets already. So by using we've been already, producing about yearly.
Yes, so we have used that data as one of the masks for mangroves. JAXA has, I think, a 20-year series 2000, I think 99, I'm not sure, 99 or 2001 onwards, I guess. Right. So we have used that data as a mask, and we are further doing a species level classification in using Sentinel-2 or even list-4 data.
Yeah. Yeah. For us, we don't have any classification at this point in time, just only for the
yes.
over mangroves. But we can maybe further work the ecosystem. Right.
Right. Absolutely. Yes.
Yes. Thank you so much. So
Nikhil, will you be, should I try the OceanSat?
Yeah, we tried OceanSat. The resolution is relatively coarser. So though we got some of the signatures, but for species level classification, I think it was not very suitable because it is having a coarser resolution.
Okay. Yes. My question is, do you want to speak to the OceanSat slides too? Or should skip?
No, I request you to please play that.
Okay, we'll see if. Do you have another question?
No. I think just he suggested we just play it. I think is there a voice to come from it?
Let me turn it up.
From Space Application Center ISRO. I will be talking about Ocean Color Monitor instrument on board OceanSat 3 payload and how it is being used for studying the coastal waters. So OCM3 was launched last year with improved capabilities.
If voice is
compared
faint,
to
then I
OCM1
can
as well
give
as
the
OCM2.
voiceover if you want.
If you see, both OCM1 and OCM2 was having 8 bands with broader spectral width, but OCM3 is having 13 spectral channels and narrower bandwidth. So bandwidth has been reduced from 20 nanometer if you see in OCM2 to 10 nanometers for OCM3. And the signal to noise ratio is more than 500 in most of the cases, which was not the case for both OCM1 and OCM2. So in this slide, I'm showing the website where you can find the OCM3 data. So there is a website known as Bhuneti, which has been developed by National Remote Sensing Center of ISRO, and both level 1 and level 2 data products are being hosted at the website. The level 1 data is being processed using state-of-the-art atmospheric correction algorithm. The flowchart, simplified version of the flowchart is shown on the right. So each and every step has been carried out very carefully and has been validated. So if you see the table, we have listed out the level 2 products which are being generated at the Bhuneti website. And these products have been validated from cruise data which was carried out during February of 2023. So the cruise track is shown on the bottom left, and the validation of remote sensing reflectance using which most of the products are being calculated is shown on the right side. So both the spectral shape as well as magnitude, we are very close to the in situ values. Now I'll be showing you some of the operational products that have been generated using OCM3. So the figure on the left is an RGB image which shows the river discharge as well as coastal turbidity off Gujarat coast. The image was created using the Rayleigh corrected reflectance of OCM3 from February 2023. And on the right, we have shown all the 3 operational products here. So we have shown chlorophyll concentration, diffuse attenuation coefficient, as well as total suspended sediment. So variability in all the products we can see is very nicely captured in both coastal as well as open ocean. Similarly, for Bay of Bengal, we have shown an RGB image. Here the river discharge as well as coastal turbidity can be seen in the northern part of the bay. And the image was similarly created using the Rayleigh corrected reflectance of OCM3. So for this date, the 3 operational products are also shown on the right. So we have shown chlorophyll, KD and TSM. And here also we can see that variability is very nicely captured. Higher values of chlorophyll, for example, can be seen near the coast. But as you move towards the open ocean, value gradually decreases and in some part it is less than 0.2. So thank you from my side. The contributors I would like to name: Anurag Gupta from SAC, KN Babu from SAC, and Saurabh Tripathi from SAC. And I would like to thank Director Space Application Center, Nilesh M. Desai, especially for encouraging this work. And I would also like to thank the members of CEOS Coast as well as the CEOS point of contact in ISRO. So thank you, everyone.
Right, I think we have some time if anybody has any questions for Dr. Musa.
I have a question. Can you hear me?
Yes, we hear you.
Okay, yeah.
Yes, I can hear.
Is the OCM data available to the public?
So presently what you can do is you can go to Bhunidhi website and just register, and maybe in few days they will give you the access.
Okay. Thank you.
Terrific. Next we have ISRO's shoreline bathymetry. Fingers crossed this one works.
Hi everyone, this is Ratish from Space Application Center, ISRO, India. We are involved with the CEOS Coast on the coastal products of Bay of Bengal. East coast of India is subjected to various coastal issues, mainly the coastal erosion. And the region is prone to tropical cyclone with an average of 2 to 4 cyclones per year. The coastline is a hotspot of major development activities, and there are thriving tourism industries. The coast of Bay of Bengal has various critical habitat like the largest mangrove forest, the Sundarban Delta, and is dotted with numerous coastal wetlands. Among them, there are nesting grounds of endangered species. The importance of Bay of Bengal is due to the presence of these vital coastal habitats that are facing immense pressure from both the anthropogenic activities and the natural disaster. As it is said, the coastal erosion is one of the major issues of the region. We have carried out a study to quantify the coastal erosion of the entire Indian coast. We found that the east coast of India is more dynamic due to the presence of open sandy beaches and a deltaic environment that are subjected to high wave activities. Based on the data cube structure, we have formulated a method that select the satellite image with a certain criteria of tidal condition and extract the yearly shoreline. This is an example of the shift in the inlet of Chilka Lagoon, which is the first Ramsar site of India. During 2002, to improve the health of the stagnant waters of Chilka Lagoon, an inlet was manually dredged along this region. The inlet gradually shifted to the north due to the growth of the southern spit. The northward shift of the inlet is approximately 8 kilometers during these 15 years. Subsequently, the northern spit have undergone severe erosion and have reduced this, and its size got reduced significantly. This is another example of severe erosion along the coast of Bentha. Around 10 kilometer long stretch of the region is under severe and persistent erosion. From 1990 to 2020, the shoreline have shifted to more than half a kilometer. We can also see deposition to the south and growth of the spit to the northernmost part of the coastal segment. The second product is on shallow water bathymetry using SAR images. Deposition of sediment from the river creates bathymetry features like tidal bars and shoals at the river mouth that are dynamic in nature. The information of these depositional features are important for modeling coastal processes like storm surge induced coastal inundation. A method is formulated to estimate the depth of these depositional features based on the spatial variation of the backscatter from the SAR images. We have estimated the bathymetry of the depositional features at Hooghly river mouth, where we have ingested the SAR-derived bathymetry into the model domain. The details of the bathymetry contour can be seen in the updated SAR-ingested model domain. This domain shall be then used to simulate coastal processes like coastal inundation during the cyclone. Preeti and Anoop have contributed to the presentation, and I express my sincere thanks to Nilesh Desai, our Director, Space Application Center, Dr. Rashmi Sharma, our Deputy Director, and Paul and Mary from NOAA, and also Rajiv Jaiswal from ISRO headquarters. Thanks a lot.
Are there any questions?
Okay, next we have a presentation from Geoscience Australia. I think that one will come through loud and clear. They're going to talk about several projects.
Hi, my name is Stephen Sager. I'm the CEOS Coast representative for Geoscience Australia, and I look after our Coastal Earth Observation Group here at GA, and I'm here to give a bit of an update on activities that GA has been contributing to CEOS Coast since we last spoke at the CEOS seat last year. So in that time, I think in our last update to CEOS SIT, we were just commencing the launch process along with our collaborators in Digital Earth Africa of the Digital Earth Africa Coastlines Initiative, and this was launched shortly after last CEOS SIT at the Geo Blue Planet Symposium in October 2022. Now, just to step back a bit, this was a project that came from Digital Earth Australia. The coastline product is a annual Landsat product with maps mean sea level coastlines across the continent of Australia, going back for 30 years in Australia and going back to the year 2000 in Digital Earth Africa. Now, it was a CEOS Coast initiative. CEOS Coast really helped underpin the process of taking the learnings for Digital Earth Australia through to DE Africa. And this process has now been commenced through DE Africa. And since the launch back in October, they've really led the charge in developing a whole raft of comprehensive training materials. These kind of things you can see on the course on the left here, being led by in-country experts. This is an online course that users across the continent can learn how to use Digital Earth Africa coastlines in Jupyter notebooks, learn how to tailor some of the algorithms to their individual regional coastline studies. And since then, these kind of uptake, use cases and sort of value demonstrations have really been promoted. And just recently, there's been a few media pieces that have gone out through the USGS. And this is a bit of a symbiotic relationship in which they were able to demonstrate the benefit of using free and open USGS Landsat data. And they've helped us to promote some of those uptake and use cases both across Africa and to Australia. So where are we going next? In terms of our next generation products at Geoscience Australia, the next cab off the rank for us is looking at what we've called the DEA intertidal elevation products. Now, we've had a product called the National Intertidal Digital Elevation Model in Australia for a number of years now. This was developed on Landsat data, so at a 30-metre resolution, you can see on the left there. 25 metres in our initial Australian Geoscience Data Cube data format. So it's well overdue for an upgrade, and what we're doing in this project is incorporating Sentinel-2 data and moving this into a resolution of 10 metres. We're taking what was a static product developed over a 30-year time period into annual updates to be able to capture these dynamic coastal environments, and we're moving away from what was really a waterline-based elevation model to a new pixel-based method. We have a raft of other different types of tidal modelling improvements. We're also looking at intertidal exposure, which is one of those applications stakeholders have been asking us to help underpin things like migratory species and habitat management. But although that resolution is improved, which you can see here in the updated digital elevation model, one of the main features is actually moving to that temporal update and going to an annual product instead of a 30-year product, because this really starts to open the doors to start looking at change in these environments. We're starting to align with looking at impacts and pressures in land cover sense to try and see if we can look at drivers for coastal erosion. So this is one of those products that will be able to apply to these more dynamic areas instead of a more static elevation model. And at the core of this, our approach and how we look to contribute to initiatives such as CEOS Coast is to take an open source approach for these type of algorithms and when we're applying them, especially in this open data cube world. So we aim to develop all of these workflows, things like our coastlines and our intertidal products, so that they're transferable across all kinds of ODC platforms. So whether that be CSIRO with the EASY and EEL platforms that we utilize a lot in CEOS Coast, right through the Microsoft Planetary Computer. And this starts to open up a raft of opportunities for international applications and collaborations. And already as part of this CEOS Coast initiative, we've been able to collaborate with NOAA and CSIRO over the last year to take some of our coastlines learning and apply them to Chesapeake Bay. And you can see on the bottom right here, we've actually been able to take some of our really early workflows for this new intertidal product and apply them in northern Vietnam. Now this is taking inputs from Microsoft Planetary Computer using their Stack API. Now, this is very early days, but this really changes the game for us. We've used to be very Australia-centric, or where we could stand up these digital Earth implementations, but being able to apply them wherever we can get that ODC input or of time series data through Stack is really powerful for us. And it's quite interesting looking at these different environments that we're not used to in Australia. And you can see in these intertidal areas, for example, in Vietnam, you have far more features that are pulled out here that may be through aquaculture and other applications like that. And in terms of what that means for emerging opportunities and how we contribute to CEOS Coast, there is a new initiative that's being run through the Department of Foreign Affairs and Trade in Australia called the Marine Resources Initiative, and Geoscience Australia is one of the collaborators on this. And it's really looking at developing regional assistance to our Southeast Asian partners to help them with marine spatial mapping and generally managing their marine environments. So one of the things we're looking at Geoscience Australia and my group in terms of Earth observation is we're collaborating with CSIRO to see if we can help develop EO data infrastructure, things like the CSIRO EASY and EEL data cubes, and then provide a capability and assistance to apply our coastal products workflows such as coastlines and the intertidal elevation product suite. Now, these initiatives are still taking form, so we're not able to announce them yet, but they're looking to form the focus of what GA can contribute to the CEOS Coast over the coming year. So in summary, CEOS Coast has been a really valuable initiative for us, and we're looking forward to supporting it into the future. And I look forward to seeing if I can answer any comments that I receive after the seminar, and thank you for your time.
Yes, it's the middle of the night in Australia, so none of the Geoscience Australia folks could join us. But if you do have questions, we can connect you with them. And next up will be Sung Young Sun, who will be presenting on storms and water quality.
Okay, can you hear me?
Yes.
And see the presentation?
Yes.
Okay, hello, my name is Sung-Yeon Son. I'm working in NOAA Nested Star Coast Watch application team. Today, my presentation is about impacts of hurricanes on water quality properties in the U.S. coastal waters. To investigate impacts on water quality properties enhanced by hurricanes passing over the U.S. coastal waters, water quality data and products from in-situ measurement and from the ocean satellite sensors such as water temperature, salinity, chlorophyll pH, turbidity are used for this study. I'm going to show some preliminary results in the Florida coastal waters, focusing on Hurricane Ian in late September last year, 2022, which is the second deadliest storm to strike the continental USA in this century as a Category 4 storms. And it passed over Florida coast with intense landfall.
Sung-Yeon?
Yeah.
The slides aren't advancing. Do you need Mary Beth or someone to advance them? You're still in the.
No, okay, I'll do that. Yeah, actually,
Oh.
I'm just yeah.
Oh, okay. Sorry.
Yeah, and I will show some Chesapeake Bay result. Here's a daily Beers SMPP true color images from September 18th to October 5th of the South Florida coastal waters. You can see there's a significant changes after Hurricane Ian passed. This animation you can see. And next slide is selected daily images before and after Hurricane Ian, September 23rd and 25th, and September 30th and October 4th. Actually, these true color images are showing vertical suspension and freshwater plumes with the high suspended sediments and colored dissolved organic matters around the coastal areas. Next one is composite images of fierce SMPP, SST, 7-day composite before and after hurricanes, September 20th to 26th, 2022, or after September 29th and October 5th. As you can see, there is a significant decrease in sea surface temperature after Hurricane Ian in the most of the area. Next one is chlorophyll images and before and after hurricanes. There is a increase in chlorophyll concentrations after hurricane in the most of areas. Especially, it's not, although it's not that much as SST, but it's increased along the coastal areas. This one is KD490 images, which is water diffuser attenuation coefficient. It can be used as an indicator of water turbidity or water clarity. So this image shows similar to chlorophyll concentrations after Hurricane Ian. KD490 values significantly increased along the coastal waters. This one is high spatial resolution satellite images from PlanetScope, which is the commercial CubeSat sensors. This data is 3-meter spatial resolution. Actually, previous years is about 750-meter spatial resolutions. These images are from before and after Hurricane Ian around the southwest of southwest Florida coastal area. It's around the Charlotte Harbor area. As you can see, after Hurricane passed, actually that passed September 28th, you can see significant increase in suspended sediment. It's very brownish in September 30th and October 2nd, but in October 6th images, the brownish colors disappeared, but the inside of estuary is very black, which is about the very high sea dome water. Sea dome contained waters. I also derived the suspended sediment products using the default the algorithms. This is not original algorithms, but it shows very high suspended particulate matter materials corresponding to the brownish colors in the true color images. And next one is PlanetScope images, SPM, in October 6th. The suspended sediment SPM concentration is not very high, but the true color image shows a very black or very dark inside of estuary. I think probably suspended sediments is sank and moved out, but still very high sea dome in the estuarian waters. This is another example for the Chesapeake Bay. These are MODIS aqua images. Left one is SST, 7 days before and after Hurricane Ivan 2004. Right side is chlorophyll composite images, similar to Florida area and BS images. SST decreased significantly after hurricane, and the chlorophyll concentrations increased after hurricane in the most of Chesapeake Bay area. This is the last slide. This is a time series of daily averaged chlorophyll A, fluorescence chlorophyll A, and turbidity from the NOAA buoy in the Stingray Point, which is southwest of Chesapeake Bay. You can see the red line is the day of the hurricane passes, and the blue line is 7 days before and after hurricanes. As you can see, turbidity is significantly increased in the Chesapeake Bay, in the station, and the chlorophyll A is increased around the hurricane passes, but about 3 or 4 days later, it's dropped. Then it increased again. These are all I have today, and this is still ongoing research. So if you have any question, please tell me. Thank you.
Thanks very much, Sun Young. In the interest of time, if anybody does have any questions for Sun Young, I'll ask him to put his email in the chat, and you can email him directly. We do have a very quick presentation next by Jorge Vasquez from NASA on salinity. He's not with us today, so because it's sort of the middle of the night for him too, I think because he's trying to do the first talk.
He must be earlier.
Always. 37 years.
I'm not hearing any audio. Does anybody else hear audio?
Yeah. And the audio goes through?
There's nothing to see.
Sorry.
Okay, I think we might just skip this one if everybody's all right. I'll make it available to you. But we seem to have an audio problem. Oh,
You need to take that sharing because I think
the importance of this
oh, there we go. Okay.
it was associated
So
with
we do have the salinity again,
which impacted.
and I'm going to restart it.
I wanted to give a overview on salinity and the integration into CEOS Coast, and also talk briefly about some of the data sets available. And just to start out, this is an example of salinity taken from the Soil Moisture Active Passive Mission, or the SMAP NASA mission. It was taken on February the 5th of 2023. Obviously, blue is low salinity, white is higher salinity. One of the things that the importance of this particular day is that it was associated with the atmospheric river events, which impacted California, and you see the fresh water off of California also. So again, this is just an example, one of the examples of the impact and the importance of salinity in coastal regions, obviously, and you know, the impact of atmospheric river events, flooding, that increases water and volume of water in rivers and associated, the associated signals in coastal areas. And this image shows that very, very nicely, the large signals that you see in the coastal areas. This is just zooming in on that day again off of California. You'll see again the freshening associated with the atmospheric weather event. This happened to be just an example of from the Russian River, which is in Northern California, just north of San Francisco and Santa Rosa. And you see again the freshening event associated because of the volume increase and the flooding that was associated with the atmospheric river events, and also the impact in the coastal region. Again, this is taken from the NASA's Soil Moisture Active Passive Mission. Another example that I would just say quickly of the importance of salinity in coastal regions is obviously the issue of acidification, and all of these impact the biodiversity changes that that can occur in the coastal regions. So salinity is definitely a factor in all of that. And some of the data sets involved, I already mentioned NASA Soil Moisture Active Passive Mission, or SMAP. And the product is gridded on a 0.25 degree spatial resolution. And the feature resolution, though, is about 60 kilometers. So even it's gridded at a quarter resolution, that the feature resolution is about 60 kilometers. There are several products. There's the JPL CAP product also, and again, the remote sensing product. And all of those products are available through the NASA Physical Oceanography Distributive Active Archive Center, or PODAC, which is located at JPL. So all of these salinity data sets are available through the PODAC. Then there's also the European Space Agency, or the Soil Moisture Ocean Salinity Mission, funded and managed through ESA. And it provides weekly ocean salinity products at level 3 that are available on a 50-kilometer equirectangular grid. And all of these are also distributed through ESA as well as Copernicus. And I think a very, very exciting thing in terms of the future is, in fact, the Copernicus Imaging Microwave Radiometer, or SIMR. The launch date is going to be past 2025. Sampling will be at about approximately 5 kilometer at a monthly time scale. And the microwave radiometer will also provide sea surface temperature. So this is really exciting in terms of having both sea surface salinity and sea surface temperature measured from the same satellite, obviously continuing the applications also to coastal regions, which will be critical. And thank you.
Okay, just like before, we will hold any questions. Next up is Jerome Benveniste to tell us more about the ESA physical oceanography products. You have between 5 and 10 minutes, sir.
Share. Sharing. Okay, full screen. Hello, everyone. So a few words about the trillion products that we are producing at ESA in different frameworks. One of them is the climate change initiative. So with this activity, we wanted to go closer to the coast as possible to answer the question, is sea level rising at the coast in the same manner than in the open ocean, which we had done 10 years, in the last previous 10 years. And the idea was to put all the altimetry missions together and check the intermission jumps or gaps, or eventually, and also focus on the drift. So we did that, and now we're going closer to the coast. And a couple of years ago, I reported that we had made some progress, and now we have a new product which is out. And this product is, of course, much better. And we find a way to salvage a lot of points, which we call virtual station, just like in hydrology, where we simulate a tide gauge at the coast. And so we have much more points, and we have like 300 more points than before over the whole globe. And also we are getting closer and closer to the coast. And you can see points where we have data from the satellite less than 3.4 millimeters to the coast. And so this is the map of the virtual station, where we take the last 2 kilometers of the track and we average those 2 kilometers, and we superimpose on the regional map, the global regional map of sea level rise. So this data is available. A few examples where you see on the bottom left, we have the trend, the function of distance to the coast, and this in this case, the sea level is rising differently close to the coast, like 2 kilometers, rather than 10, 15, 20 kilometers away. We have other examples where here in northwest India, also it's rising, and off Corsica and in southeast Pacific, it's rising. We also have identified places where it's decreasing, and in particular in South China Sea here, and we're looking at the Mekong Delta, and we're interested in looking at the impact of river runoff on this sea level close to the estuary and the delta. We have found places where it's also decreasing, and many places, of course, where the trend is more or less constant. This is all explained in the documentation that comes with the product, and the product is available. And so this is well, I'll skip because we're a bit of time, but basically this describes the product, where we have extended the data set up to June 2021. We have applied different solutions, and we are producing over the globe 1,012 virtual stations, which is 300 more than we knew how to do a couple of years ago. And of course, we've worked a lot on the statistics. We're going to continue looking at optimizing a little bit more, and looking at the river runoff in different places like the Mississippi and the Mekong. And of course, this is scientific data project in preparation. At ESRIN here, we have developed a certain number of science clusters, and one is the ocean, for which we are covering, we're trying to cover everything. And each of these activities are producing products. So I won't go into them, but this is like we've had more or less 40 products, 40 contracts which are ongoing, which are each of them producing products. And these products, well, a few examples. We have an activity on the Baltic. So the Baltic has produced a special data set on the sea level in the Baltic, which is a very difficult place because of the coast and the islands, and is covered by sea ice in part of the year, and so on. So here we have a DOI where you can have the information about what we've done in Frontiers of Marine Science, and how to access to these 25 years of data freely available. And now we're relaunching an activity, a sequel activity on the Baltic, which will produce more, better, and more diversified data, including biogeochemistry. An activity that we had also that proves data is this coastal and open ocean comparison performance activity. And here again, you have a DOI that gives you access to the data and website where all the documentation is available. And this was the occasion to develop new processing algorithm to provide better data set closer to the coast. A sequel of that activity was the idea to put together the hydrology community and the oceanographic community in the coastal zone, and and look at the interaction, understand the processes between river discharge and coastal sea level. So it's a bit upstream from the CCI, which is really looking at long-term drifts and closer to the coast. And again, here you have all the data and the documentation. Everything is published, the product validation report and so on. And we made a lot of outreach on this activity at the Hydrospace workshop and also the Coastal Altimetry workshop. HU Coast Park and so on. So again, this is just a few information to say that we have a certain number of documents that came out, like the state-of-the-art review, which is a very interesting document to start with, to understand what was the challenge and what kind of products we're aiming at producing, and the global products, level 2, level 3, and level 4. So this is the Macintosh, which is behaving. Let me go back to full screen, and a scientific roadmap to tell us where we should be going in the future. Okay, so this is the 18 test data sets that we have produced, where you might be interested to take 1 or 2 in China, in Canada, in Zambia, and in the German Bight or in the US coast and so on. Again, we have also developed an ESA altimetry virtual lab, where you can go and process the altimetry data the way you want it, where you want it, and so on. So this is also a source of data that you can generate yourself with customized processes. Just a few clicks and you have data over your region. So don't hesitate to go there. It's funded by the Network of Resources of ESA. And if you want really to consume a lot of resources, you can always put your credit card, and we'll find a way to charge it. There is also much more we have developed in order for people to understand how to access the data in one-stop shop. The Open Science catalog. So you go to this website, and then you click Ocean, and you see this is the time span of all the data that we have. Of course, you can't see what's written on that column because it's too small, and that was on purpose to show you how many variables we are covering. And then you click and you see each of these variables. On the left side is more or less all the variables that you can access. So click on Open Science Data and navigate and find the data which is the most interested to you. I'll put this maybe in the chat for people to be able to click on it. And this is all the references of things I have talked about here. And so thank you for your attention. And this is the CEOS Coast motto, where our ambition is to facilitate.
Thank you so much, Jerome. Can you also put your email in the chat in case people have questions for you? Because, there it is.
First name, last name, I think that is IT, which is regular.
We are running short. I'm going to take, I know we had promised 3 more. We are going to save the SWOT talk as a bonus track. If you tune in to the official compilation of the video, but because we do need to wrap up here, I'm going to switch first to Erin Urquhart. Are you available?
Yeah, I am free. Let me share my slide.
She is going to speak about the PACE mission. If you can keep it to 5 minutes or under, that will save us time for one last presentation before we have to wrap it up at the bitter end as well. Thank you, Erin.
Absolutely. Can you see my slides? All right, good to go. Well, thank you so much for inviting me to talk about the PACE mission, and I will try to keep it brief. So PACE is NASA's next great investment into understanding ecosystem response to changing climate. PACE will deliver the most comprehensive look at ocean color and its biological and ecological processes in NASA's history. It's also going to help expand and extend NASA's long-term record of ocean observations, and we will also monitor atmospheres, including clouds, pollution, and aerosols. And lastly, PACE will reveal diversity in both our terrestrial and our marine food webs. So just quickly to go kind of through the PACE observatory, it is a 3-instrument observatory. PACE is an ascending polar orbit that's sun synchronous. It'll have a local equatorial crossing time of about 1 p.m. Each orbit is roughly 90 minutes and the inclination is 90 degrees. And like most of our Earth observing satellites at NASA, the altitude is just shy of 700 kilometers. So the first of the three instruments and kind of our reason to be is called the Ocean Color Instrument, or OCI. It's being built at Goddard Space Flight Center, and it is a hyperspectral scanning radiometer. The OCI instrument will provide continuous spectral coverage from the UV through the near infrared. Every step will have a 5 nanometer resolution, but the spectral steps will be 2.5 nanometers. OCI will also have 7 discrete shortwave infrared bands, which will be really helpful for coastal atmospheric correction. OCI will have 2-day global coverage, a ground footprint of about 1 kilometer at nadir. And importantly, OCI is a tilting instrument, really to mitigate sun glint. And so it's going to tilt 4 to and aft so that we can mitigate looking into the sun. There's also going to be 2 contributed small but mighty multi-angle polarimeters. So the first is HARP-2, which is a contribution from University of Maryland, Baltimore County. It is a wide swath instrument that pretty much mirrors the same swath as OCI. It is a hyperangular polarimeter. It is multispectral in the blue, green, and red and near infrared band, but there's polarization in all of these bands. It will have a 1 to 2 day global coverage and about a 2.6 kilometer sample distance. The second is a multi-angle polarimeter. It's called SPEX-1. It's a beautiful complement to HARP-2. It's a hyperspectral spanning the UV to the near infrared, but it's multi-angular. It has a 2 nanometer spectral step for total intensity, and it'll have polarization spectral steps that will vary from 15 to 40 nanometers. The HARP or SPEX-1 is really great for aerosol characterization. Just so to give you kind of a sense of how these 3 instruments are going to kind of act together, that these 3 instruments are going to make a breakthrough in ocean, cloud, and aerosol research. And together, they're going to provide far greater information content than any current or planned instrument suite for ocean color, aerosol, and cloud observations. So in addition to advancing the way we see Earth, PACE is going to support practical applications that will benefit society. PACE is one of NASA's first missions to have a dedicated applications program. So PACE will support all 5 of NASA's applied science thematic areas. PACE will support human health through air quality and water quality monitoring and prediction. PACE will help ensure safe and sustainable seafood. It will help assess and mitigate the impacts of disasters and hazards. It will offer insight into the dynamics of terrestrial vegetation, as well as provide information on crop, wetland, and forest ecosystem health. And lastly, PACE will help improve climate models and our understanding of the Earth's changing climate. Because this is a CEOS coast, I'm going to focus this slide really looking at our water resources and aquatic ecosystems and how PACE can benefit this thematic area. So PACE will provide hyperspectral chlorophyll data, phytoplankton community composition, and pigment data. So this is going to really help contribute to our understanding of aquatic ecosystems, which can benefit and inform identification and tracking of harmful algal blooms, assessing the health of fisheries and aquaculture, monitoring marine food webs and dynamics, and studying aquatic biodiversity, evaluating and maintaining ecosystem health. So for all of you sitting in the room or online, you're just saying, Erin, just show me the data. I did want to add this. So the amount of data products, both kind of our standard products as well as our test and advanced products from PACE it keeps going. But I did want to just show you for the aquatic, marine, as well as the water resources thematic areas, these are both the standard, the test, and the advanced data products that PACE will provide. Because like I said, we're going to be supporting terrestrial as well as atmospheric remote sensing. You can access the data table with this QR code to see the rest of the data products as well as the metadata and the ATMs. So I only have 5 minutes, but we have a lot of resources that you can check out on our PACE applications website, as well as there's the PACE Science website. This includes everything from data product descriptions, access to our simulated and proxy data sets and characteristics, all of our PACE technical memos and other documents, On the PACE applications website, we have community newsletters that we release quarterly, lots of information and kind of the one place to get the up-to-date information on what's going on with the mission as well as the applications program. And for brevity, I'll leave it at that. Happy to take any questions. Always obviously happy to chat about PACE and NASA Water Resources. So reach out if you have additional questions. Thank you.
Thank you so much, Erin, for telling us a little bit about the upcoming PACE mission. As I mentioned, we'll save SWAT for a bonus track. That is a current mission, not an upcoming mission, but the data is still being leveraged. And we do have, I think, time for one additional video by Megan Kofer from NOAA, talking about submerged aquatic vegetation.
Hi, my name is Dr. Megan Kofer.
And let me make her be quiet for just a moment.
And I'm a research scientist for the Coast Watch Applications team and global. Hi, my name is.
Just put a pause.
Hi, my name is Dr.
Big circle.
Yeah. Okay. So Megan is going to talk a little bit about some other future work that supports COAST for mapping seagrass and using commercial satellites. So hopefully you all can hear that. It's only 5 minutes, so we will end after her. Sorry about that.
Hi, my name is Dr. Megan Kofer, and I'm a research scientist for NOAA's Coast Watch Applications team and Global Science and Technology Incorporated. I'll be sharing some ongoing efforts focused on mapping seagrass using various high spatial resolution satellite platforms. Seagrasses are incredibly important ecosystems, serving as a source of food and habitat, providing erosion control, and offering carbon burial at rates orders of magnitude higher than that of tropical forests. While their ecosystem services are well documented, their global coverage is not. Current global estimates of seagrass cover range nearly 30-fold, from a mere 150,000 square kilometers to over 4.3 million square kilometers. And this figure on the right compares the area of seagrass currently mapped in dark green to model predicted seagrass area in opaque green across the 6 global seagrass bioregions. Field observations of seagrass cover and density can be prohibitively costly and time-consuming to collect. Historically, difficulties in satellite-based mapping of seagrasses were due in part to insufficient spatial resolution to capture spatial heterogeneity and insufficient spectral resolution to differentiate seagrasses from spectrally similar benthic cover such as algae and corals. Recent advancements in satellite sensor technology have allowed for the development of workflows leveraging high spatial resolution commercial satellite platforms such as those shown in the top row here, and for high spectral resolution freely available satellite platforms such as those shown in the bottom row. Our current efforts for mapping seagrass coverage have focused on each of these platforms in different scenarios, leveraging advantages of different sensors to fit the spatial requirements of specific seagrass meadows and spectral requirements in optically complex waters. Most of the work I'll be showing today focuses on the WorldView 2 and WorldView 3 sensors, which were launched in 2009 and 2014 respectively, and collect data at 2 meter spatial resolution across 8 multispectral bands. We have developed a reproducible and semi-automated method for mapping seagrass cover using WorldView 2 and WorldView 3 imagery, representing the first reproducible processing regime for data collected from these 2 sensors over aquatic targets. This processing regime includes pre-processing and classifying the data, where pre-processing consists of radiometric calibration, atmospheric correction, and orthorectification and mosaicing. Classifying consists of defining areas of interest, applying a deep convolutional neural network, and comparing satellite-based results to those from reference data. The same code written for this workflow has been applied to data from PlanetScope, Landsat, and Sentinel-2. This approach has been tested for over a dozen study areas across the United States, shown here in green. And this example on the right is for Back Sound in North Carolina, with a true color image shown in the top row and our image classification shown on the bottom row, both with concurrent field observations of patchy and continuous seagrass overlaid in shades of orange. Our image classification approach was able to capture the pixel by pixel heterogeneity of the seagrass bed and statistically had a 97% agreement with reference data. After demonstrating our methods for coastal waters across the United States, we have expanded our recent efforts through partnerships throughout the Indo-Pacific. Currently, we are assessing the efficacy of our approach at study areas in Hawaii, the Philippines, Indonesia, and Australia's west coast. In establishing these methods for different test sites, we will then transfer our methods and knowledge to local partners, allowing them to continue their own large-scale seagrass mapping efforts. Moving forward, we hope to take a step further and estimate carbon storage capacity of seagrass beds. Using a workflow like that shown here for St. Joseph Bay in Florida, we plan to use our image classification to estimate leaf area index, or LAI, as an indicator of seagrass density, which then directly informs our estimates of carbon storage capacity. This work can help further our understanding of blue carbon storage and refine global climate models. And finally, while our work in the past has focused on establishing baseline seagrass coverage maps for specific areas, we hope to leverage increased temporal coverage of satellites such as Landsat, shown here, for trend assessments. These time series represent a 30-year period from 1990 to 2020, again at St. Joseph Bay in Florida. Patterns in annual seagrass area, leaf area index, and both dry and fresh biomass were assessed. These analyses can be used for resource prioritization and to guide local and regional coastal management. Additionally, given supplementary information such as land use change, tropical storm occurrence, and water quality measurements, we can gain a better understanding of stressors on seagrass ecosystems and how different parameters impact their carbon storage capacity.
Yes, perfect timing, I think. So it's 5 o'clock here in Frascati, so I would suggest that if there are any more questions or comments that anyone has to make on that huge wealth of information that we've just been privileged to see, they get in contact with Mary Beth. She's put her email in the chat, you all know her anyway. She's the leading force here. So please just drop any questions you have. She will direct them to one of the speakers, and I would imagine share any videos that you would like to watch again. But in the interest of time, we must wrap up because we have a bus waiting for us. But I'd just like to thank the Coast Ad Hoc team. I'd like to thank Mary Beth and Paul online there, and Rafmi. I don't know if she's online, but thank you very much to your leadership. Sterling job. I mean, amazing wealth of information we've just been privileged to see. So thank you very much for that. And look forward to talking more about Coast in the next day or two.
Thanks, everyone.
And thank you for everyone who joined online.
Take care, all. Enjoy dinner.
What time is it?